In this video, I am going to discuss how to compare slopes of two straight lines and determine whether the lines are parallel or perpendicular or neither. The objective here is to actually find the slope from the y is equal to mx plus b formula, that means slope-intercept form of a straight line. Use this form of a straight line to find the slope and then compare the slopes to figure out whether the lines are parallel or perpendicular. Remember, once again, we are using this format: y is equal to mx plus b, where m is the slope, b is the y-intercept, meaning the y-intercept is at b 0, b. I am going to cover a few different cases, so let's go ahead and start off with this one. These are two equations of two different straight lines. Our objective is to figure out whether these two straight lines are parallel or perpendicular or neither to each other. Remember, to compare two straight lines, we need to compare their slopes. So we are going to express this equation in the slope-intercept form, which, by the way, is going to give me y is equal to 2x plus 7, which is very easy. I hope you know how to go from here to here. So that tells me that the slope of this first line is 2. Similarly, if we solve for y in the second equation, just divide both sides by 5, you will get y is equal to 2x plus 1/5. Note that the second equation also has slope 2, because I expressed both of these equations in the form y is equal to mx plus b to get the slopes. Now both of these equations have the same slope, meaning that these lines are parallel to each other. If two straight lines have the same slope, then the lines are parallel to each other. If the lines are parallel to each other, they have the same slope. It's bidirectional conditioning. Now let me consider a second case. In the second case, I'm going to consider these two equations. My first equation is 3x plus 2y plus 1 is equal to 0, and my second equation is 4x minus 6y plus 1 is equal to 0. Now we are going to simplify these equations, both of them, and solve for y to get the form y is equal to mx plus b. If we did that, we get the following from the first equation. If we solve for y, we get y is equal to negative 3 over 2x minus 1/2. And from the second equation, we get y is equal to 2/3 x plus 1/6. So we get two equations for the first one, m1, let's call it. I'm going to call this one my m1 and this one my m2. m1 is equal to negative 3 over 2 and m2 is equal to 2/3. Obviously these two numbers are not equal because one is positive, one is negative. So the lines under consideration, this line and this line, they are not parallel. However, at the perpendicular, to find that out, what I am going to do, I am going to multiply m1 and m2. m1 is negative 3 over 2 and multiply that by m2, which is 2/3, and see these 2 and 2 cancels, 3 and 3 cancels, that gives me negative 1. So that tells me m1 times m2 is equal to negative 1, which is the condition for two straight lines to be perpendicular to each other. By the way, this could be simplified to m1 is equal to negative 1 over m2, which some of you may be more familiar with, which is basically saying that slopes are negative reciprocals of each other. So this is that statement, and this is equivalent statement. So these two particular lines are perpendicular to each other. Now if the first condition doesn't hold, which means this one, that means they are not equal, and the second condition doesn't hold, which means that their product is not negative 1, or equivalently the slopes are not negative reciprocals of each other, then the lines under consideration are neither parallel nor perpendicular. So we have covered pretty much all different cases. These are the all possibilities. The lines could be, so let me summarize, the lines could be parallel to each other when the slopes are equal. So if they are parallel, then the slopes m1 must be equal to m2. If the lines are perpendicular to each other, slopes are going to be negative reciprocals of each other. m1 is equal to negative 1 over m2, or equivalently m1 times m2 is equal to negative 1. If neither parallel nor perpendicular, then we call it neither. I hope that this discussion was helpful. Thank you very much.